Hello and welcome to the Gilli Pong Analyses Atheism. I am going to do my best here to go through another video. In this case, I started looking at a few videos that were pretty funny, I think. It's not directly atheism, though. It's more like scientism, another ism. We like to analyze the isms here, so I'm gonna try to do my best to. And it's Brian Cox. And this is the video I kind of saw first, and then we're gonna go into another video, and it's about 23 minutes each of them, so I'm gonna try to go through them. I'm not gonna talk a lot. I'm just gonna allow the information to filter in, and I'm just gonna try to do my best to ask questions that make you think a little bit differently. So Brian Cox. Start from the beginning.
Oppenheimer. So I don't know if anyone's seen the film. I think it's a masterpiece, Oppenheimer. And I was interested in Oppenheimer. I got interested in him as a character quite a long time ago because I discovered that he gave the BBC Reith lectures in 1953, and they've almost been obliterated from history because they're really hard. One of the things I grew up watching was one of the people was Carl Sagan, who I don't know if anyone's old enough will remember. I think Carl Sagan's Cosmos, and it was on the BBC, 13 episodes, 13 weeks, and there's very little science on television at that point. 3 channels or something, I think, at the time. But Cosmos was on, and Sagan presented astronomy, and he talks about astronomy in the solar system and the universe, but he put it in a context, the context of our civilization. And he was explicit that this way of thinking, this way of interrogating nature, trying to understand the natural world, is vital for our survival as a species. It's central to it's one of...
Okay, here we are using certain words like species. We are a certain species. It's vital for us to investigate nature, to see if we can survive. So very, very doomsday-like conversation.
One of the necessary foundations of civilization. So it was a polemic, and so I genuinely think that science has the thought process, the things we discover, and that way of thinking about the world, acquiring reliable knowledge about the world, is the way we do it. That's important. So I do have an agenda when I talk about science on television or live shows or whatever it is, because I think that it's important. So there's an underlying feeling there that I have that these. I said once, actually, someone asked me once, why do you want to present a program on BBC One, for example, about astronomy? And I said, I think science is too important not to be part of popular culture. Yeah. So I really believe that. So if you believe it and you get a chance...
Okay, he's talking about that science needs to be a part of popular culture, because popular culture doesn't really have maybe the intelligence to grasp these concepts that he's going to talk about. It's quite interesting because when you look at the topics they're talking about, it's doomsday, it's global warming, we have to leave the planet, we have to look at the planet in a certain way to understand it. But it's completely different than from, for instance, the Christian perspective, where you have a deeper understanding of what the world is and why we are here. But for a scientific mindset, that's very hard to grasp. So let's look at nature and let's try to figure out what is going on.
Look again, you get the chance, the platform to do it, then it would be ridiculous not to try and take that. Right? I do think that scientists, if they want to and get the chance, have, in some sense, a responsibility to talk about it. Because, and there are obvious things we could talk about. One topically actually is Oppenheimer. So I don't know if anyone's seen the film. I think it's a masterpiece, Oppenheimer. And I was interested in Oppenheimer. I got interested in him as a character quite a
My perspective of Oppenheimer is like a psychological operation to make you believe that we have something called nuclear weapons, that we can. And he was facing this, quoting Bhagavad Gita, I have become death, I have become destruction, pointing to the fact, and I think I haven't seen the film, but I have an instinct that it's about what if it doesn't stop? What if we blow up the world? What then? And of course, that is very interesting to the scientific mind because it kind of gives them a certain kind of elevation of how science can be destructive and have such a huge impact on our existence.
long time ago because I discovered that he gave the BBC Reith lectures in 1953, and they've almost been obliterated from history because they're really hard, and so we don't tend to think of it. But in those lectures, when I found them, I saw this scientist who obviously famously played a role in developing the atomic bomb, so in delivering the means by which we might destroy ourselves as a civilization, and he obviously knew that, and it tortured him. So that what that made him do was think about how we might avoid doing that.
Yep.
Right. So he started thinking about politics and society and civilization, and are there any lessons from this tremendously successful approach to acquiring reliable knowledge, which we call science? Are there any lessons that we could apply in wider society? Certainly wasn't saying that scientists should run the world, right?
Can you understand the logic from my perspective? If you don't believe in God, there was no mention of God in any of his description of it, of how we can understand society. If we look at the bomb, then we'll understand why not to bomb society.
He clearly decided that was a bad idea, but some of those lessons, you might call them transferable skills, which perhaps goes back to the heart of what we're talking about, are important, I think. And one of them is not kidding yourself, not deluding yourself into thinking that you understand something. So really understanding that the world is very complicated.
Yep.
And
here is the crux of the problem, and I think he describes it very well. And it's kind of like if you don't have a mirror and you're not looking at yourself and not seeing what you're saying. I feel Brian Cox is doing that right here. It's like if you... And I think he's a little humble towards it, but we have to also look at these people with this kind of eyes. They are telling you how the world works while they don't know. And we have, if we listen to them, we get filled with this certainty that they know something. The scientists know something.
many ways of it's difficult to understand a black hole, right? A collapsing star, but it's also difficult to understand how to run a society. It's really tricky. So there aren't simple answers. There are, and from we could talk. I'll stop talking about that, but I could talk about it forever. But it's
how we can run a society. It's interesting what words are being used.
That I think is always, when I got the opportunity to talk about science, in my mind, that I enjoy talking about it. I think it's wonderful. I get excited about talking about these big ideas. But also in my mind, there was also the things that Oppenheimer and Sagan, Richard Feynman and other of my heroes had also said, which is that there is a responsibility to talk about this way of thinking and the things we've discovered.
They feel like it's a responsibility to talk about these complex ideas. Note what we were speaking about. Concepts, ideas, in my mind, and propping up theoretical scientists, theories.
Which leads us into one of the areas that I think you're masterful at, if you don't mind me saying, is overcoming a common trait that you see with lots of intelligent people, the curse of knowledge, that you know an awful lot, but your ability to translate that knowledge and make it accessible to 7-year-old children or to a mass audience on the BBC is a unique skill set in itself. And I'm interested in exploring, how do you go about being able to communicate these complex, difficult ideas in a way that people can understand and start to get to grips with?
This is a very good question. If you think about it, if you see it, these are complex ideas. We're not talking about concrete elements. It's like an idea how to build a house instead of building a house, and something that lasts for centuries. It's the theory of building a house. Or has the house ever been built? And what was the theory behind that house that was built? It's the theories. And I remember when I was working in the shipyard, looking at the guys with the soft hands coming with their suits on and their hard hats. They were always looked down upon because they didn't know the practical understanding of, or pragmatic understanding of, how to get things done. They were always putting out theories out there and then fighting with the guy who was in control of either the construction site or something, and they were saying like, this can't be done, this is a stupid idea, or something like that. So this is kind of how I look at it, and if you follow it from that perspective, then you understand how illogical it is.
You know, in part, it's about that. We talked earlier about honesty, being honest with yourself, about how difficult it is to understand some of these concepts. So if you've been through the process, and I find this, I'm quite slow quite often. I don't understand, I don't understand. Oh yeah, that's it. Then what I do usually is just talk about...
Kind of a humble brag here, you know. He's been propped up as some intellectual, so he's trying to, like, I'm slow. It takes me a long time to get things. So, but typical humble brag kind of strategy of how to make himself look humble.
About the way that I understand something. And it's quite often the way that a 7-year-old would understand something, because you've been... I find anyway, if you're honest with yourself, then if you really do understand, if you really deeply get something, you've been through that process. So you've seen how difficult it is, and it's almost always difficult, right? So you're not gonna wave your hands around and obfuscate and say, when you see someone doing that, and you see it at university, you know, I saw it with people who taught me. You can tell when they don't really understand something because they fall back on jargon. Yep. And so wave their hands around and go, no. And usually that's because they've not been through that process, and they're sort of not tricking you, you know, but it's probably that they're tricking themselves into thinking.
Are you
that
comfortable saying, I don't know?
This is the basis of science. It's fundamental. I mean, Richard Feynman, we mentioned, you know, it's a Feynman Nobel Prize winning physicist, also worked on the Manhattan Project, actually. One of the greats, a great teacher as well. And he called science a satisfactory philosophy of ignorance, right?
A satisfactory philosophy of ignorance. So if you are ignorant and you're trying to understand something, but now we live in a world where you have to believe in science, trust the science, and that's exactly the opposite of what he is speaking of. So it's very beautiful to see a real scientist speak here. I feel he is a true scientist, but he's being propped up as some incredible intellectual because he can put the difficult concepts into the common language so other can understand. So I kind of understand why Brian Cox is, propped up as someone. But it's like it doesn't really matter what he's speaking of to us in our day-to-day life. And that's the funny thing also. Black holes and something that is happening in space far, far away.
And it's a really deep point, actually, because he meant that all knowledge starts from you, the individual, accepting that they don't know. You start with, I don't know how that works. I don't know why the sky's blue. I don't know why the leaves are green. I don't know why the universe is the way that it is. And that's you have to start from that point, and then you try to build a reliable picture. It's a model of the world in your mind. But being a scientist, of course, it's about doing research. And that means that you're going to the edge of knowledge always and being extremely comfortable standing on the edge of the known, the dividing line between the known and the unknown, and trying to find out a bit more. So you have to be delighted to not know. And excited about it, to go back to what you said, passionate about not knowing in order to make any progress. And I think that's a skill. It's about
like his skill is articulating things that inspire you. So he's an inspirer, I feel. Like being at the edge of the known and looking into the unknown. This is a very interesting thing. While being dumb, being relaxed and being dumb, being ignorant, not knowing. But there's so much things that are not seen and not evidence-based and empirically measured that cannot be seen if you're only looking it through your senses, which is my personal understanding of reality. And I feel like sometimes these sense-based entities that are continually looking at something and then developing theories and ideas about what is going on, they can often fall flat on their face when it comes to doing something actually that makes sense.
Jettisoning any fear of the unknown, isn't it? And I think a lot of time we get into a lot of arguments, as a society about things that are pretty unknowable at the moment. We don't know. So even basic things like, did the universe have a beginning? Right. And we know that the universe was very hot and dense 13.8 billion years ago. That's good. We call that the Big Bang. But whether
we call that the Big Bang, do we know if there's a beginning? And this is a question that is, now you're standing on this known versus the unknown, and he's looking at the unknown and he's saying, we know it is the Big Bang based on observations and measures. But it really doesn't know, you know.
that was a beginning in time, whether the universe existed in some form before that, what it means to talk about the beginning of time. We don't even know what time is. Right, we don't know. We've got some sense, by the way, that it might be built of smaller things, but we can leave that alone. So, but the thing is that it's key, isn't it? Because a lot of people talk with great confidence about, well, how I know how the universe began. I know why the universe began. The answer is, how can you? Nobody knows. We don't know yet, and that's interesting and exciting.
Yeah.
And that's the key. That's the starting point for building a reliable picture.
But we live in a society where we pillory people for not knowing. We demote people for saying, I don't understand. We criticise people for not having all the answers. We promote people who bluff and bluster and trick their way to the top, don't we?
We can stay apolitical, but
we can. But I'm talking of them, whether that's political or even in business. The sort of people that are leading businesses are just those that are brave enough to say, I know all the answers, even if they don't. We're all making it up. And I think it's really powerful if you can sit here and say, I don't know, then that's great for everyone.
Yeah, and if you think about it, so we do accept in certain professions that it's good to be to know what you're doing. Like, for example, flying a plane.
Yeah.
So being an airline captain.
Doing an operation.
A surgeon,
This is a very interesting point, and I can point out that, like, knowing how to, like, who knows? I remember being always having to pick up my girlfriend back in the day that became my wife. She was working at a school for pilots, and there was a door that you had to press a button to open. And every time I came to pick her up, there was a pilot stuck there. He didn't know how to open the door, so he was just stuck, waiting for me to open for him or something. And then I always had to point the button, press it. But the pilot didn't have common sense to open up the door, and it was just my personal observation and experience. So I was wondering, what do these pilots really know? Are they really capable of flying these planes? And then I found out, after talking to the pilot that was teaching everyone how to fly and keeping pilots airborne, they have to go through annual and triannual exams that they have to finish in order to be, maintain their license. And there I found out that the ones who really knew were the ones who wrote down the manual. So the manual makers are the ones that know. Because they have been collecting the information of how to fly the plane, and the pilots are usually just going through the manual, and it's like a action item list: press this button and then do this, and very hard for you to remember all these sequences that you need to fly the plane. But you have to know how to manually fly it, of course. But the manual makers are the ones who know, and according to this logic, they should run society.
Designer of a nuclear reactor. There are things where knowledge, and experience are valued. But you're right. I suppose it's, if you look at how our knowledge, and I used the term before, reliable knowledge, how that knowledge was acquired. It was acquired by people starting from the basis they didn't understand. And then the moment, this is critical in science, the moment that some new data appears, some new evidence, some new observation comes in that conflicts with your picture of the world, then you start to be interested. You start to be excited. You go, well, if I'm wrong with my picture, then I'm delighted because I've learned something. I can rule that picture out, and then I can go on to a new picture. So you have to be delighted when you're shown to be wrong, because you've learned something.
Yeah, I just wanted to kind of talk about this video and show you this video where they don't know. The theoretical physicists don't know. But they know a few things. But do they really know, is my question. Do they really know? And there's another video where you can see the opposite of that, where you see the manufactured discussion about black holes.
Could black holes be the key to a quantum theory of gravity?
This was Carlo Rovelli's book. I can probably show it here. Carlo Rovelli. I think it's, maybe I'm mispronouncing his name or anything. I think he's Italian. I think the name was Reality something. Let me see. Reality. This is the book. Reality is Not What It Seems by Carlo Rovelli. I'll just show you the. Some physicists, mind you, or not many of them, are physicist poets. Okay. So you're a poet in this way. But Carlo Rovelli, this book, if you look at it, Goodreads is a good site to see it without promoting anything. This is the book that I was reading. And it was very interesting. It was very fascinating. It really inspires you if you are want to go into the STEM field and understand science from a different perspective. Because he's kind of going through what we know, how the atom was, how Democritus figured out the atom by thinking like, okay, if we have a string, and then we have that, and we have that, and then we have that, in the end there will be only one molecule, and that should be the atom. And it's highly recommended. And there is like the journey to quantum gravity, and this is where quantum physics currently stands in. I remember, like, I was always trying to find this bridge between the spiritual and the scientific, and this was kind of the bridge. Like, when you look at things on a quantum level, then you are figuring, like, what is gravity on a quantum level, you know? Very interesting stuff. Very fascinating. But you're not going to find God there. But maybe you will, you know? I'm not saying, you know, yes or no, but it's like spirituality and theology and understanding why we are here and what is the Big Bang and all that stuff. I feel like that has already been talked about in a deeper fashion on another level, on a philosophical, on a theological level. So let's continue here.
Deeper theory of how reality, of how space and time works. Black holes are interesting because we have a place called the event horizon where we think that we have full control of the physics. We understand what's happening, but there is a fundamental clash between our two basic theories of nature, both quantum theory and general relativity together. And the quest to unify those two great pillars of 20th and 21st century physics into what's often referred to as a quantum theory of gravity is in some sense a holy grail for theoretical physicists.
Look at this language. It's such a beautiful way to realize like how misguided a human being can become, even though it's extremely intelligent. The holy grail of theoretical physicists. Stephen Hawking talking about this quantum entanglement and all these different theories and stuff. And it's all based on a picture. Let me show you. I'll go back here. If it goes back, that is. Like this here. This here is interferometry. Interferometry. Like there are the EHT, the Event Horizon Telescope, is a network of telescopes around the planet that have taken a picture, and the picture is that of a black hole, like EHT, black hole. If you just search for that, you should get a picture. And this is the famous picture, the Event Horizon Telescope. And you see this picture here. I don't know if I can just see the picture somewhere here. Yeah. So this is the picture of a black hole. I'm sorry. I don't want to look like I'm a conceited douche. But here, this is a black hole where we have the event horizon. And if you just look at how it was put together, this is the idea of how it was put together. So they're seeing all these notes, and they're using a piano to show you how they are creating the picture. This is maybe what they're seeing. You know, and they slowly add a few more telescopes to try to point in that general direction. slowly, they start filling in the gaps. And there you get Ice Ice Baby. So this is how the telescope network works from that perspective. And he is speaking of it. Look at all the graphics and all the stuff they are having there. It's all worked in a computer. All studied. The event horizon. And and we just saw how beautiful it was, looking at it from not knowing. But now you have this on BBC television.
So black holes are forcing us into a deeper understanding of what space and time are. And in that sense, I think it is fair to say that black holes are the keys to understanding the universe.
Okay.
I'm Brian Cox. I'm a professor of particle physics at the University of Manchester and the Royal Society Professor for Public Engagement in Science. And amongst other things, I'm the author of the book Black Holes, the Key to Understanding the Universe.
So not only is he trying to convince you of the theories being true, but he's also selling you a book about where he's selling you the theory about that this is true. So there's monetary gain in it too for them. And this is the key to understand the universe. Don't look at God. Don't read about God or pray or believe in anything like that. No. Look at me. Look at me. I can tell you why we are here if we look at the pictures.
The idea of black holes goes back a long way, actually, back into the 1780s and 1790s. There were two.
You see, this humbleness, how his hair is cut, how his t-shirt he is wearing is shaggy, how he is wearing these skinny jeans and these sneakers, and he's sitting on this white carpet, and you see all these books behind him. It's such a production. He's propped up as an intellectual deity, an icon to worship. Listen to this oracle of the scientific, or scientificism, or whatever you can call it, scientism. It's another ism, another belief system.
Physicists, mathematicians, natural philosophers, whatever you want to call them, working at the time, that had the same idea apparently independently of each other. One was a clergyman called Mitchell, and the other was the great French mathematician Laplace. And they were both thinking in terms of an idea called escape velocity. The escape velocity is the speed you have to travel to completely escape the gravitational pull of something, a planet or a star. So for the Earth, for example, the escape velocity from the surface of the Earth is around 8 miles a second. If you go bigger, you make a bigger, more massive thing, let's go up to a star.
8 miles a second in order to escape the velocity of Earth gravitational pull. Okay. So that's what Elon Musk is trying to do and NASA is trying to do. We've already gone to the moon, but they destroyed all the technology. And it's like 60, 70 years later, and we still haven't gotten any good pictures from the moon. But we got a big good video and stuff from Mars. Is this believable? I'm just asking questions. I'm not sure.
Star, for example, like the Sun, it's somewhere in the region of 400 miles a second. The escape velocity increases because the gravitational pull at the surface increases. What Mitchell and Laplace thought, and I think it's a very beautiful idea, is they imagined in their mind's eye, well, can you go bigger? Can you...
They imagined in their mind's eye. Can you go bigger? Remember, these are Nobel laureates. They get awards for picturing something in their mind's eye that sounds cool and can be theoretically discussed among others and challenged.
Imagine more and more massive stars, giant stars, such that the gravitational pull is so large at the surface that the escape velocity exceeds the speed of light. And then you wouldn't be able to see them. To understand why black holes cause so many conceptual problems, it might be worth just describing very, very briefly what a black hole looks like.
Okay, now he starts shifting the language, and suddenly this theoretical thing, a black hole, can cause theoretical conceptual problems. Or this concept can cause other conceptual problems. But he was saying suddenly, like the black hole that is a center of gravity that takes the speed of light to run away from, that is suddenly becoming real because they took a picture of it using the ice baby. Dum 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 dum. Okay.
So, a black hole, what do you see from the outside? Well, there's...
By the way, this interferometry that I just showed you, it comes from the Event Horizon telescope that I showed you earlier. Just to show you, I'm not just playing around with you. Like you go to their website and you scroll down. What was it? And like in this web page you can find what is interferometry. Let me see. Does it show me here? Yeah, the EHT images of M87 are among the most vetted interferometric images ever published. Ice, baby. Dun 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 dun. Look at the sky. Don't look at yourself. Don't look within. Don't believe in anything else except the science that we are trying to figure out. Oh, where was this? Interferometry. Long Island interferometry. Read more. Yeah, they saw it behind Sagittarius A star. And it's like they're playing with you, right? What's a star? What's this picture? It's like, what is this? Like if your mind is in the gutter, you just see one thing. Like this, what is this? So you get this sent on a messenger or something, and you're like, what the heck is this? It's like a bad picture of some organ. And it's Sagittarius A star. You pronounce it A star. Like this is the funny thing. I feel like I'm being messed with, and everybody's so smart and trying to understand it, and they it's like you're in church and there's a funeral and you really want to say a joke or something, and it's like that kind of feeling I get when I'm looking at this.
An event horizon surrounding the black hole, in some sense it defines the boundary between the external universe and the interior of the black hole. And if you go across the boundary into the interior of this sphere, then even if you can travel as fast as the speed of light, you can't escape the gravitational pull of the black hole. But another description of the event horizon, which confused people all the way through the history of black hole research actually, was the idea that the event horizon, when viewed from the outside, is a place in space where time stops.
Concept. Time. Time stops. The concept stops. Time, which we kind of interpret as the Earth spinning on its axis, where the sun rotates and creates the year. Time that we can't measure, but we can have a clock that we can depict in this video, and we can show it stopping, and we're like, oh my god, time has stopped.
And that's a direct prediction of Einstein's theory of relativity from the external perspective. There is a central problem, though, which is still not solved, which is what lies at the centre of a black hole. You might think
amazing amounts of money is being spent on this research, by the way.
Think of it as an infinitely dense point to which this massive star collapses. So what are we picturing? It's this thing called a singularity. Actually, it's not right to talk about the centre of a black hole, really. Just even in pure general relativity, when you look at a nice map of a black hole, the so-called
Is my mind in the gutter? This is the Penrose, Roger Penrose. I've been hearing about him too. Roger Penrose. There's a scientist that figures out mathematical equations. So apparently this is what a black hole is. This is what Interstellar, another Christopher Nolan movie, Oppenheimer, Christopher Nolan, Interstellar, where Matthew McConaughey, all right. It's just gonna go with a southern drawl into a black hole. Wow. And this has been in horror movies. The Event Horizon is another horror movie I remember where this was shown, where we can create a wormhole by putting a paper together, because space and time is just paper. And then you can cut a hole in it with a pen. And you get so fascinated by this, especially if you're with this atheistic scientific mindset.
Penrose diagram, named after Roger Penrose, what you see is that space and time are so distorted that in some sense their roles swap. The singularity is not...
Space and time swaps. Nothing and nothing does nothing, and nothing happens. Concepts can be switched. Sorry.
Really a place in space at all. It's a moment in time. And actually, it's the end of time. But the nature of that thing was not, and is still not, understood. And for many...
Once again, we are back to the same problem. We are showing you all this fancy stuff that we don't really understand.
Many years, actually, until quite recently, then people thought, well, there we are. We have a problem with the singularity. We don't really have any access to it. We don't have the conceptual tools to explore it. So it may remain a mystery for a century.
We don't have the conceptual tools. Concepts. If we just try to analyze that, Alan Watts. Yeah, I started listening to a lot of his stuff on YouTube because it was free and was readily available for some reason. There he describes a concept, and that the ego is a concept. And you can't really do anything with your ego, he was saying, because the ego is like the equator of Earth. It's a concept. You can't wrap a birthday present in a concept. It's the ego does not therefore not exist. So you can't do anything with your ego. You just have this moment, which is outside of time. But while you're in it, it creates time. So here we have somebody saying, here we don't have the conceptual tools. What do you need then? Do you need to connect to Starlink and connect to Elon Musk's Google everything before you think about it, learn it, have a vocal transmitter that can transmit it? We have an understanding of the reality. And we are trying our best to figure out a black hole. You know, do a Stephen Hawking voice, and then you have the conceptual tools to comprehend the center of a black hole.
It's not clear what to do. The great revolution in black hole research was to notice that actually there are conceptual problems, not only in this extreme place, at the singularity, whatever that might be, but at the horizon.
The horizon. The purpose of this letter is to show that this indeed may be the case. It seems that any black hole will create and emit particles.
What Stephen Hawking showed in a landmark couple of papers is that
a black hole therefore might have a finite life.
If you consider quantum theory, quantum mechanics, in the vicinity of the horizon of a black hole, then you find that they glow.
Quantum theory, quantum mechanics, theories, again, concepts to grasp concepts. Let's grasp a concept with another concept, why don't we?
They produce particles. They have a temperature. This thing that we've pictured in Einstein's theory as pure geometry, just distorted space and time, actually emits particles. It's called Hawking radiation. And Stephen, in his 1974 paper, gives this hand-wavy description, which is kind of a nice way to picture what's happening. The idea is to zoom in the vicinity of the event horizon of a black hole.
Remember, remember, this is the only picture they have. And it's using interferometry to picture it. But in this, it looks cool, right? You see it.
Happening as a series of particles coming in and out of existence all the time.
Coming in and out of existence, all the entangled
and so
particles.
One of those pairs of particles.
You can see one particle here,
is on the inside
one here.
Of the event horizon, and one is on the outside.
What is outside and what is inside?
It can happen that the one on the outside, instead of merging back with its partner again, can escape into the universe.
It just can go back out into the universe.
From the black hole as it goes, therefore it's shrinking.
Then it shrinks.
Which means that one day it will be gone.
It can just disappear.
That has profound implications. So black holes are not eternal prisons. They have a lifetime. One day, whatever's in there is returned.
This looks much better than this. The other picture.
The question was, the central question that was immediately raised by those calculations is this. What happened to all the stuff that fell in?
Yeah.
The way I've described it, the way Einstein's theory describes it, is somehow that stuff goes to the singularity.
It goes into the middle.
The end of time, the region of space-time that's so convoluted and distorted that we don't understand how to describe it at all.
No, we can't even describe it. We don't even understand how to describe it. We don't have the conceptual tools to comprehend it.
But then, one day, the whole thing is gone. All that's left in the far, far future is Hawking radiation, those particles that were produced in the vicinity of the event horizon. The question is is it possible, if you could collect all that radiation, all the Hawking radiation through the whole life of the black hole, is it somehow possible, in principle, that the information about everything that fell into the black hole throughout its history is imprinted in that radiation in the far future? Is that true, or is it not true?
This is gonna blow your mind, by the way.
This is pure understanding.
You might say, why did I ask that question?
Yeah.
It seems like a bit of a random question.
It's a bit of a random
It's a very
question.
important question.
Yeah.
Information is conserved
It's
in the
conserved.
universe, as far as we know. So every law of nature that we have says that information is conserved.
You take
So
a book.
let's say that I take a book and I set fire to it,
And
I
burn it.
incinerate it, I destroy it in any
All
way
the
that I can.
particles go out into the air.
In basic fundamental physics, then it turns out that if you could collect every piece of that thing that I detonated or incinerated,
Yeah. If you take that and use the undiscovered conceptual tools, you can.
every quantum of radiation, every photon, every particle, everything, in principle, if I could just collect it all, then I could reconstruct the thing that I had destroyed. The problem was black holes, quantum mechanics, general relativity. When you put them together, you have this apparent prediction that these things erase information from the universe.
So these concepts all put together create an eraser of information. How can you believe this bullshit? It is quite astounding. Scientists, and especially the theoretical ones, are misguided. They need to figure out other ways to do something else with their time. It can erase information from the universe. We don't know anything. We have theories about what is going on. We have interferometry. We have decided to conceptually create something that is behind Sagittarius A star. And if we guide all the telescopes together, we can figure out what is inside it, where there is this hypothetical singularity, where the event horizon creates particles, and the particles escape. They just escape into the universe, and it disappears. Oh, if I use my Richard Attenborough voice, and I put out some graphical cool stuff, you might kind of understand what we are talking about, right, don't you?
This became known as the black hole information paradox.
Black hole information paradox. All
It
right.
turns out, if we fast forward to the present day, and a series of papers which are still being written, so this is still research that's happening as we speak.
Billions.
But it turns out now that the general view is that
Billions
black holes do not
of currency.
erase information from the universe. We now think you could collect all that radiation and, in principle, put it into...
But if you're an atheist, don't you just die? Don't you just get erased? Why are you looking at a black hole when you can just look at Gaza right now or something? This is such an oxymoron, and it's such a contradiction, and it's a paradox in its own paradox. It's the paradox.
We have found the scientific paradox, where there's a paradox of a paradox, making it a non-paradox in our conceptual tools.
some quantum computer and reconstruct the information about everything that fell in. But the implications of that the mechanism by which that happens, I would say it's profoundly exciting, because it really does seem to be giving us a glimpse of a deeper theory of gravity. The simple way to say it, let me say it in one sentence. It seems that space and time are not fundamental. So one view, and I emphasize that there are other views, we're at the cutting edge of research now, but one view is a field which has become known as emergent.
We are 10 minutes and 47 seconds into a video of a man in a space with white curtains in the books. But they do not exist in theoretical physics.
Space-time.
It's concepts
And
upon
so
concepts
the idea
upon
is
concepts.
that space and time themselves emerge from what?
From what?
From quantum entanglement.
Ah,
From some kind of
That's God,
smaller parts or pieces. We don't know what those things are. We don't know the nature of them.
no.
But it does seem that there's a deeper underlying theory from which space and time emerge. That
Yeah.
is what we call
God.
the quantum theory of gravity.
Ah, that's the
And
quantum
my
theory
view
of
is
gravity.
that
That's
if we're going to talk about
God.
the origin of the universe, even ask questions such as, did the universe have a beginning in time? Which we
Yes.
don't know the answer to. Then it
God
surely
created the
seems
earth
to me that
and
we
the
have to
heavens.
understand what space and time are before we can ask and have any chance of answering such questions.
We already
And black
answered
holes,
the
it
question.
turns out, are the
Stop.
objects that we can
Look at
see,
it.
that we can observe, that actually exist in nature. That
We have found the anus of the universe. We have found it. We have found the anus. I'm sorry. We found that it's behind the Sagittarius. And we will name it A star. With an asterisk, but it's not silent. The asterisk is not silent, we will use it as star. A star. As. No, don't go into that. It's anus. The anus of the universe has been found.
we can see, that we can observe, that actually exist in nature.
EHT
That
telescope.
force us down that route to ask questions, sharp, well-defined questions,
Well-defined questions.
about the
Indeed.
nature of space and time themselves. Einstein said that if you look at nature really carefully and keep pulling at the intellectual threads and keep going and just keep
going.
delving down
Down.
into what nature seems to be trying to tell us,
What nature's telling
then
us.
if you're lucky and
persistent,
persistent,
yes.
you can catch a glimpse of something deeply hidden. It's beautiful, that, isn't it? A glimpse of
beautiful.
something deeply
A
hidden,
glimpse
which
of
is the
something
deep underlying.
deeply hidden.
The anus of the universe. We found it, Frodo Baggins. We found the ring.
Structure of nature,
Oh.
the deep underlying structure of reality itself. And I think it's very beautiful. No one really knows.
This is just intellectual masturbation. Nothing else. We have just watched a scientific porn movie, and nerdgasm is just spewing all over the place. It's completely disgusting. But thank you so much for joining me. Please put a like and a comment, and even subscribe if you want to see more videos like this. This is the longest one, I believe. But let's see. Thank you so much. Ha det bra!